Thank you. So hello everyone, I'm Melis Sayın. I'm currently in my second year of my master's degree in the Construction Engineering and Management Division of METU. And I am also working as a research assistant in the same division. And today I'm going to present you the paper titled A Decentralized Blockchain Framework for Tracing Green and Sustainable Materials During Building Life Cycle. So, as you can see from my outline, I will first start my presentation with an introduction section and then continue with the literature review part, where I will mention the existing research and our possible potential contribution to these existing research. And then in the third section, I will cover the details of the proposed framework and the tools for its application. Then I will finish my presentation with the discussions and conclusions part by covering the potential benefits and the limitations of the framework. So let's start with the introduction part. As you may know, in recent years, there is a raised awareness for environment and sustainability topics, and this brings the essential demand, increasing demand for environmentally responsible construction practices, especially considering the huge role of construction industry in environmental measures. So, the green or sustainable materials, depending on the project requirements, have started to be used as a solution to meet these demands. Also considering the complex nature of the construction projects that requires high level of coordination and collaboration among stakeholders, there is also an essential need for advanced material tracing systems for these green or sustainable materials to actually meet the demanded sustainability standards, minimize the environmental side effects, and preventing the greenwashing marketing strategies. So, although these are some facts we know that the existing material tracing systems, most of them are centralized systems with limitations and some problems resulting from the dependence to some trusted third parties. So the advancements in blockchain and smart contract technologies can provide some innovative and effective solutions to overcome these limitations. So the main objective of this study is to propose a smart contract-powered blockchain framework for decentralized green and sustainable material tracing during different stages of building life cycles. So when we look at the literature review, we know that the blockchain and smart contract technologies have started to be used as solutions as immutable, trust-free, and transparent solutions. They started to be used in many different sectors for many different existing problems, and construction industry is one of the main sectors. So there are many research that focus on the management of construction supply chains. These are only a few of them, few examples of them. In the management of construction supply chains, these technologies are used considering the improved material information, improved security and transparency during the processes, and the high level of accountability and trustworthiness among the stakeholders. And also considering these mentioned benefits, there are some recent work that use these technologies in the material quality control processes where the production must meet some certain standards. And also a similar perspective can be achieved in the management of green or sustainable materials, and several work also combine the sustainability practices with blockchain and smart contract technologies. However, since there is still scarce research, this study aims to contribute to the existing literature by proposing a decentralized framework that specifically focus on the tracing of green or sustainable materials. So when we come to the details of the proposed blockchain framework, there are two different main modules in this framework. And the first one is the blockchain integrated decentralized storage system, the IPFS cloud, which is used to securely store the sustainability documents due to the limitations of direct use of the blockchain technologies in the storage of large amounts of data, to create unique content identifiers, which will change whenever their related document is altered, and finally to use multiple storage nodes to avoid a single point of failure. And the second module is the centralized smart contract model, which is used to conduct the processes of framework in every step, which include the interactions between the stakeholders, which we'll be talking about in a minute, and to manage the complex material tracing without the need for a trusted third party, and finally to work together with the Ethereum blockchain, which brings security, maturity, and cost efficiency to the framework. So when we come to the steps of the framework, it starts with the owner's adaptation of the smart contract module, which is monitored by the MetaMask system to manage the user access and integrate with the Ethereum blockchain. And the next step is the owner's determination of the required documentation of the construction materials that are used during the different stages of building life cycle to prove that these materials actually meet the desired sustainability standards of the project. Then in the next step, the contractors upload these requested documentation of the materials to prove that they use the required quality of materials during the execution of the project. And the unique identifiers of these documentation are created with the help of the IPFS cloud, as I mentioned, and the smart contract module forwards these identifiers to the suppliers for the approval of accuracy of the documents in a decentralized manner. Finally, the framework completes with the smart contract identification of the qualified materials when the suppliers confirm the compliance with the required sustainability standards of the project. So when we come to the discussions part, as an effective solution to the existing problems of construction industry, the framework proposes several benefits, which may include providing secure and transparent platform, improving materials accessible information, providing transparency, traceability, anonymity, and privacy, providing trustworthiness and secure data flow among the stakeholders, and finally resilience to cyber attacks. Also, the framework still has its limitations and some potential user risks, which include reliance on smart contracts, which can include vulnerabilities, usage of public keys, which brings the responsibility of safeguarding the private keys on users, the technical barriers for firms with limited expertise, and finally the needed financial investments for the integration with the existing industry frameworks. To conclude, in the study, considering the increasing importance for the environmental awareness, a decentralized, green, and sustainable material tracing framework is proposed as an effective solution to provide a secure, transparent, and trustworthy platform for approval of compliance with the desired sustainability standards to achieve environmentally responsible construction practices. So thank you so much for your kind attention, and if you have any questions, I will be more than glad to try to answer them.